Good afternoon. Welcome to KVS Engineering Mechanics channel. In this video session, I would like to discuss about laws of mechanics. In the mechanics, we will find 5 different laws. First one is Newton's first law. Second, Newton's second law. Third, Newton's third law. Fourth, Newton's law of gravitation. And fifth one is parallelogram law. Parallelogram law. Now, these are 5 different laws of mechanics. Newton's first law, let us take a ground and there is some object lying on the ground, and there is a vehicle which is moving on the ground at some v meters per second uniformly. It means it is not changing its velocity, it is steadily moving with velocity of v meters per second. Now, what this Newton's first law says is that this object will be in state of rest. This object will be in state of rest, or the object will be in state of uniform motion. That means it will steadily move with some velocity per second until and unless, up to what time they will be like this in this state, means until and unless if you apply a force on the object or you disturb force, you are applying some force on the object or you are accelerating the vehicle. That means you are trying to apply some force on this uniformly, some force on the vehicle. Until and that time, this vehicle will be in uniform motion or this object will be in state of rest. So this is what's called first law of Newton's first law of mechanics. That means in this vehicle, how we are applying the force? By pressing the accelerator, the more fuel will be allowed into the carburetor engine and the speed will be increasing. So the vehicle will start accelerating or the velocity will increase like that. So this is about Newton's first law. What is Newton's second law? In the Newton's second law, what he is saying is that there is an object which is moving in the space with v meters per second and acceleration of a meters per second square. This can be assumed to be in rest. This can be assumed to be in rest if you apply a force which is equal to inertia force, which is equal and opposite to the resultant force of the directional force of a magnitude mass into acceleration. That means when the body is moving with some acceleration, it will be having some inertia. If there is no acceleration, the body will not have any inertia. If this body is in acceleration, it is an inertia. So it is doing v naught meters per second square, a meters per second square acceleration. So this can be assumed to be made into rest if you apply a force of mass into acceleration, which is called inertia force on this body. This is the Newton's second law. Okay. Now, what is Newton's third law? There is a object on a rough floor, or we use just rough floor. This is having some mass m and weight mg. So, if you apply force F to this particular object, this particular mass will not immediately move. It will resist this force by frictional force, Fr. The maximum value of frictional force, Fr, is equal to mu into mg. Maximum force of frictional force resistance can be mu into mg. So, till the resistance force becomes Fr, there is a F is equal to Fr. F is equal to Fr. That means for every action, there is an equal and opposite reaction. If you are applying some force F below the frictional force, means F less than Fr, some Fr is nothing but mu into mg, this object will be experiencing the Newton's third law. That means if you apply force F, there is a reaction force Fr. There is the equal and opposite force Fr is equal to F. The equal and opposite reaction Fr, which is equal to x. If you keep on increasing the force up to Fr, it will be in rest, and if the force is more than Fr, this will be in motion. So then this F is equal to Fr plus ma. That means according to Newton's third law, we are applying some force. There is equal and opposite reaction of F till F reaching to Fr, and above Fr, the body will be in motion, and the applied force F is equal to frictional force plus mass into acceleration. So this is the Newton's third law. And about Newton's law of gravitation. So that means any two objects in the space will be having some attractional force. So Newton started calculating how much force they are in with attraction. So this is a mass m1 and this is a mass m2. Okay, this is the two bodies. That means any two bodies, and the distance between these two bodies is say r. The distance between these two bodies is r. So these two bodies are attracting with each other with some force F, and this is also attracting with some force F. Okay. Okay. So because of this attraction, it has to come to M2. So what is the maximum value of force? Like what is this force? What that means the force of attraction F is equal to universal gravity constant Z into m1 into m2 by r square. Where r is the distance between the two masses. Okay. So the example for this is that now Earth is here and Moon is here. This is m1 and m2. Okay. Now because of this attraction, then the Moon is attracting some applying some force to F. So to avoid this Moon to come towards Earth, it is orbiting around the Earth. And inertia, that means centripetal force, that means the force that is attracted by Earth is centripetal force, and that is nothing but the G into M1 into M2 by R square. That means M1 into M is mass of pole, M2 is mass of air, and R square distance between these two. Okay, this you can apply to any two objects. So this is about Newton's law of gravitation. And for example, on the Earth, if a man is standing on the Earth, so what is the force is nothing but weight of the human body, and it is equal to m into g. Now this g is having some gravitational constant, and this g is nothing but acceleration due to gravity, and it is having 9.81 meters per second square. This is the Newton's law of gravitation. Now, what is this parallelogram? Now, when you want to apply all this concept on some practical problem, whether it is an automobile which is in motion or an engine where the piston is reciprocating and the crank is rotating, whatever the cases may be, there are several forces acting at a point or at a distance. So, these forces can be resolved by a resultant. So, for example, if there is a force F1 acting and at a point, and there is a force F2 acting at a point. So, the resultant of these two forces will be a single force, or this result of this single force R. So, what is the value of R? That is the question. So, the angle between this F1 and F2 is, say, for example, theta. The angle between F1 and F2 is, say, theta. So, the F2 will be having an angle of theta here. That means, as the parallelogram, this F2 is parallelogram to this side, and this angle is theta. So, the resultant R is equal to F1 plus F2 cos theta that means R into, say for example, the resultant is say an angle alpha, cos alpha. Cos alpha is equal to F1 plus F2 cos theta. And R sin alpha. R sin alpha is equal to how much? F2 sin theta. So, first of all, you identify cos alpha. Cos alpha is equal to, tan alpha. Tan alpha is equal to F2 sin theta by F1 plus F2 cos theta. Once you find out the value of angle alpha, you can calculate the value of resultant. Now this resultant is nothing but the equivalent force that can be applied at an angle alpha in place of F1 and F2. So with these laws, the complete mechanics can be studied. So these are called laws of mechanics. The first law is Newton's first law, and it is applied to one study masses at rest or mass at uniform motion. And these masses will not be get disturbed until unless some external force is applied on them. Okay, this is first law. And second law is that whenever there is a moving accelerating body, the body can be assumed to be in rest by applying an equivalent opposite force of inertia force applied on that body. So that is the Newton's second law of motion. And Newton's third law of motion, third law of mechanics is called for every reaction is equal and opposite reaction. That means for applying some force, that means applying some force on this, for example, this board. So there is equal and opposite, whatever the force I'm applying on this board, the equal and opposite force will be exerted by the plane. So that is the Newton's third law of mechanics. And fourth one is Newton's gravitational law. And this gravitational law says that any two objects, if you take in space, they will be having some attraction force between them. And this attraction force is nothing but universal gravity constant into m1 and m2 by r square. So this is the Newton's law of gravitation. And finally, the parallelogram law says that because an object will be applied by several forces, all these forces can be replaced by a single resultant force, and that resultant force can be obtained by applying the parallelogram law. So this is about the laws of mechanics, and these are the fundamental laws which we can have to use for studying entire mechanics, engineering mechanics, or whatever the mechanics related topics, subjects, applied mechanics, engineering mechanics, strength of materials, like that. Okay, so this is what I would like to discuss in this video session. Thank you for watching the video.